aspects of quantum computing and its application in various domains. Today's session focuses on an extremely timely and critical theme in the evolving landscape of computing and information security. With the rapid advancements in quantum technologies, traditional cryptographic mechanisms are facing unprecedented challenges. In this context, understanding quantum based security solutions has become essential for researchers, academicians, and industry professionals alike. Welcome to session 9 of day 5, where we will take a hands on approach to explore quantum computing through the topic quantum cryptography, a new security paradigm, and quantum computing to context to cyber security. It is our privilege to introduce today's esteemed resource person, Dr. Anoop Girdhar. Dr. Anoop Girdhar is a renowned cybersecurity expert, cybercrime investigator, academician, and technology consultant with more than 3 decades of rich professional experience in the domains of cybersecurity, cyber forensics, cybercrime investigation, and digital technologies. He is the founder and CEO of Sedulity Solutions and Technologies and also serves as the editor in chief of Cyber Time newspaper and Cyber Times International Journal of Technology and Management. Dr. Girdhar holds a PhD in computer science along with MPhil and MCA and has made significant contributions to both academia and industry. Dr. Girdhar has delivered hundreds of expert lectures, FDPs, and training programs at national and international platforms. He has served as a resource person for AICTE, IGNOU, NITTR, IIT Delhi, and many reputed universities and institutions. He has also conducted a specialized training program for CBI Academy, CERTN, DRDO, Indian Army, BSF, NSG, ATS, and various law enforcement agencies. As an accomplished researcher and innovator, Dr. Girdhar has published more than 75 research papers, authored several academic books, and holds multiple national and international patents, including a patent granted in Australia. His core areas of expertise include cybersecurity, cyber forensics, cyber laws, artificial intelligence, cloud computing, mobile security, and open source technologies. We are truly honored to have such a distinguished expert with us today. I now request Dr. Anoop Girdhar to kindly begin his session. Before we proceed, a quick reminder, please keep your microphones muted and during the session to ensure a smooth experience for everyone. If you have any questions, feel free to drop them in the chat box. We will address them during the Q&A session at the end. Now, without taking much time, I humbly invite Dr. Anoop Girdhar to kindly take over the session and enlighten us with his valuable knowledge and experience on quantum cryptography, a new security paradigm, and quantum computing in context to cybersecurity. Over to you, Dr. Girdhar.
Thank you so much, Kanika Sharma. Thank you so much, ma'am. And thank you, Dr. Pawan and the entire team of RKGIT. So thank you for inviting and to connect with your audience. It's being indeed a pleasure to be a part of a wonderful conference. And this topic, I think this is really privileged to be a part of such a good topic, because that's a next generational topic, next era for computing. So we are supposed to work more on that, like what are the real time challenges, what are the real issues. So I would love to talk on that. Again, as I am more into a security person, so I'm majorly engaged with the law enforcement agencies, uh, academic, and especially to the corporate for investigations. But if we'll talk about the next generational issue, then even we have to talk about with the next level problems, next level security challenges, especially in terms of like cryptography, as the topic said by Ms. Kanika. So in the same way, there are many things if we'll talk in terms of cryptography. So we are talking about in the case of computing, what is computing all about, and what is the level of computing is like, increasing day by day. So we are supposed to talk about what is this quantum and quantum related issues. I would just love to share my screen, and then I'll talk more on that, like what is the real time challenges and real time issues being covered into this particular regard. So just give me a minute. Let me share my screen to all. Yeah. Yeah. Is that my screen is visible?
Yes, sir.
Yeah. Perfect. So I think that screen for that screenshot, this PPT is there, right? Perfect. Okay. So what is quantum and quantum computing? Especially, I would like to talk more in the context of along with cybersecurity, and obviously today we are also talking about in the terms of AI.
So your
So
PPT
this,
is not visible.
then what is visible? Uh,
Only preview is visible.
the preview is visible. Okay, just give me a minute. Mm, okay, just give me a minute. I'll open the PPT separately then.
Now it's
Yeah,
okay.
now it's fine.
Yes,
Perfect.
sir. Yes.
So in this session, I'm going to show you some practicals also. Means this time I try to incorporate some practicals for all of you. So I have 5 6 different practicals which I want to show you in terms of cloud and even with the real time challenges with the quantum and what all the quantum computing issues being raised. So I would like to show you certain practicals, obviously with using some machine learning or data science algorithms. And apart for that, because computing means today we are talking about more like in terms of complex architectures, we are talking about big data, we are talking about blockchains, we are talking about various different technologies. So whenever there are various different technologies, how to handle such data and such technologies using this computing, especially quantum computing, and in context to using the era of this quantum. So what is quantum? Let us first of all discuss about the concept of quantum computing. So if we really talk about quantum part, okay, uh, what is a classical computing model? I hope we are aware of, like, we have zeros and ones. So we generally talk on the terms of binary representations, and we talk about what are the algorithms specially designed based on zeros and ones, because that is a concept of classical computing model. But in such scenario, if we'll talk about, then really you trust on zeros and ones, because today for high complex issues there are various different type of challenges are coming across. So today if we'll talk about the quantum and quantum related issues, then actually it is qubits. So we are not talking about bits, zeros or ones. Now we are talking about the concept called qubits. I think you can see the symbol also, right? So we are talking about the concept of qubits, and you can follow my mouse cursor so that you can able to work out. It is basically nothing but the concept called as a superposition model. So where superposition means, let us say we will talk about the square, means multiplications of that. So power, we are talking about the power part. So the qubit, whenever we talk about qubit, so it is basically talking about the two good values of representation of ones and zeros. So both are simultaneously being considered. So it's a kind of a group. You can say it's a clubbed model where we are not only talking about a binaries, but we are now talking about qubits, and each qubit have a superpositioning model where both simultaneously can be processed. So even two dimensionally or multi-dimensionally, we can even further later we can go into the multi-dimensional part. But how we can handle the values of qubits. That is, again, the values not at the one time you're talking about zeros or ones, we are talking simultaneously zeros and ones both. So that is why it is another word of quantum computing called as superpositioning. So how superpositioning is helping, and how, especially in my one of the previous session in FDP, I've seen like various different content and challenges were there in terms of talking about like AI. You want to implement AI, but how can you implement AI? And the problem is again computation. So how many of you are really aware of like new processors being introduced? We were Right now we are talking about like CPU, we talk about GPUs. I hope that much you must be aware. For AI you need GPUs for processing, calculations and all. But have you heard about NPUs or TPUs kind of processors? you know NPUs and TPUs are there, especially TPUs. If you'll talk about like tensor flow processing units are there. And even most of these days laptops are coming, the latest laptops are coming with NPUs. Basically it is giving you the power, ultra power processings. Yes. So I think I'll open chat also, some replies are also coming. Okay, so yes, ultra power processings are coming. So latest issues are, you must go through, you must check the NPUs are available, TPUs are available along with CPU or sometimes GPUs. But think about, what about like if we'll use these TPUs and GPUs and NPUs, and we are trying to correlate and combine our projects, and we use our systems for just to create a program. But let's say we use one API, one program, where that program is to be processed from some remote servers, from cloud servers, where in case of cloud we have quantums. So the next generational programs, quickly what we have to do, all the professors need to work out on all, right? So what is the best practice if you really want to start with the programming and developments or other challenges where you have a high computational issues? So in that case we'll talk about superpositioning values and qubits. So it's a quantum bits like qubits, right? So can you correlate and think about the quantum, or you can think about the complex programs? How many of you really held or worked on certain quantum some complex programs, quantum algorithms? uh, yeah. So there are various different programs are available, or especially if we'll talk about cryptography generally. Yeah, Dr. Sandeep, you're right. So there are various things. If we'll talk about like, especially if I'll talk, say hardcore coding and distributed architectures, and especially you want to compute like a blockchain, or yes, sure, Lakshmi Kanji, that's a wonderful algorithm, Shor algorithm. I will also discuss about Shor algorithm because that is wonderful part of a quantum. So there we can certainly talk about various different yes, Amita ji, Shor algorithms are very very important. Along with that there are three more algorithms which are connected to even Shor, and new research papers if you'll just explore, you will find that basically they are either trying to like divide your number of bits, encrypted high encrypted bits, into a smaller bits. And so you are trying to make it a isolated, or you can say a distributed level of packages, where one package is nothing but it could be a kind of a chain of data set, and that data set is to be get processed on certain areas. So we'll certainly talk about Shor algorithms and various other algorithms, right? So many things are being introduced and new concepts being introduced, and we are supposed to talk about various different things in this regard. Okay, now what is this all about? So quantum, what compute means you can do. So we are talking about high complex problems in the seconds versus years using a classical computing. Means I remember, it's not today, but I believe almost 15 years before, 14, 15 years before, I remember we used to call about like RSA algorithm for 64-bit RSA algorithms, right? So that was one of the algorithm, and that time some news or some paper, I hope I read, it was mentioned that if we'll apply some brute force attack on RSA algorithm, it will take 2 into 2 raised to power 56 years if you apply brute force attack on RSA algorithm. So think about, which is quite impossible. That means 2 into 10 raised to power 56 years. So can you imagine like the time taken to just to process that, how much time it will take? And today we are talking about, even we already have a RSA 8K, 4K, 2K, 8K, all algorithms. And especially if I'll talk about many real time business applications are based on RSA and AES, like, or various other such algorithm. For symmetric AES, and for asymmetric we use RSAs and all, right? So think about if we can get into more into such classical issues. I hope even you will take GPUs or TPUs or NPUs for processing, it won't help you. So that is the problem, is not in the case of your computing. It is like the problem that we are not multidimensionally we are not handling the data. So that is the core challenge. And from this particular challenge, if we'll talk about, we must try to solve such kind of problems using quantum computing. So what would be the challenge? The challenge is next generational cybersecurity algorithms are almost going to obsolete. Many more applications are about to being hacked. The and if it is powered with AI, now new concepts, like if we really powered these kind of things with AI, so out of a corpus, I hope you heard about corpus, right? Corpus is like a collection of data set, huge data set. And data set means now my data set is on big data. So I'm big data, like, okay, I'll give you one example. I was in one of the conference in last month, and I met with one of the this electrical appliances, one of the very good renowned company in India, very good products and very expensive products available, and they started working with IoTs. So today, according to their CIFO, what they said, that, sir, can you imagine, we have the challenge that how to handle that data, because we are unable to handle, and we are unable to identify what the activity is being performed on our system sometimes. Because can you imagine, daily, where we are talking about IoT means, if you talk about one of the protocol called MQTT, so they were already implementing MQTT. Somewhere only 2 bytes of header, and in total size of the packet is of 15 bytes. Such kind of data set, if they used to pick from their IoTs and their all electrical appliances in India, where they have the IoT in compliant data. And can you imagine what is the size of the data? Can you realize, like, within a day how much data they can produce? And they need to compile that data, and they need to process that data. Excuse me. So you can't imagine. The answer which I received from them is, sir, we used to receive I'm sorry, we used to receive 9.2 petabytes. Yes, Dr. Sandeep, you are very near to that. Are zettabyte, Lakshmikant ji, it would be a time. It will certainly, we'll be going to reach to zettabytes and all. That was 9.2 petabytes daily from their IoTs. Now you have 9.2 petabytes. Can you compute? Can you really analyze such a level of data? Think realistic models. And then you realize the problem statements, the data handling issues, then analytical issues. And on that basis, so let's say I want to take that data which is unstructured data, data in the form of various different files or spread it across from different devices, different locations, various parameters, and now you have to somehow go for some management level decision, some computation you required, and in that case how you'll manage such data. So even they are interested to for quantum, but obviously budget is one of the very big issue. But I think if you are on the cloud computing, yes, you will get on Amazon, on Microsoft Azure, and especially Google, they already produce their results with the quantum computing with a high scalable part up to certain level. But although we never say it is a scalable results, but yes, it is more scalable result, because the first and most important part of the data handling is not to handle the data directly and think about the real time data, right? So if you have a real time data, to handle such real time data, what is the best practice? We'll try to isolate and we'll try to create a small clusters of data. So we need to extract the clusters of the data from the real time process, and then we have to process. And multiple clusters being identified, and if we'll place it one by one, we need multiple servers. So either we'll deploy it on the multiple servers, right? Otherwise, the best practice is, yes, Dr. Sandeep, quantum computing can handle, but for that we need to create the APIs. We need to process those APIs, and then only you can figure it out. Because directly you can't. Directly you can't. You have to pick that corpus, convert that data, isolate that data, and then certainly you can process big data, right? So by if you have a different like HDFS or GFS data or HDFS data, suppose you have Hadoop file system storage or architecture sort of. In fact, one of my research was there, one of my student who got a PhD. Now 5 PhDs awarded under my supervision, and 2 PhDs were also awarded where I was a co-guide. So 5 PhDs I was a main guide. So in one of the PhD thesis is available on the Shodh Ganga. You can try and figure it out on Shodh Ganga, and you will find that, see the way how we are talking about. We worked on ultra compression techniques applied, and we created a new file system architecture. So we created a new file system, and we claim like, you give me 2 GB pen drive, I can store 2 exabyte data into that 2 GB pen drive. All right, that is the way how we are handling. And then and obviously in that case only the condition is we want networks, we want internet storage and connectivities. So basically the backbone is something else, and we are handling multiple activities and multiple architectures into it. So it's a hybrid model sort of, where we create a new file system architecture on that. So yes, with API you can handle big data, and you can take it to the quantum perfectly. That is possible, right? So think about how we can go and how we can produce such data and how we can manage that data. What are the real quantum issues? So solve high complex problems in the second versus years. In the seconds you can handle such data, and as compared to the years. Become essential for the big data processing. Yes, quantum will help you for big data handling, and act as a supplement to a classical computing, not replacing them. Obviously, there are various different challenges. Means everybody is now talking about quantum. Doesn't mean now we have to leave the classical computing and simply switch to the quantum computing. It is not this era. Probably next decade, means not today, but coming in next decade or so, somewhere we'll talk on these kind of things, because we try to mitigate those challenges, and new research being being committed on these grounds. So probably we can talk on that. But yes, today we cannot switch. What is the right approach for quantum, and with the, especially if I talk from the cybersecurity perspective as well, from AI perspective as well, I always recommend that instead of going through switching, let us start hybrid model, right? So we have to think about from the hybrid perspective. Collect your data, do all your classical computing model, But whenever you need a high computation, now you need to decide which type of computation you want. So the being a professors, and especially into the being a senior authorities and all, it is our duty to identify, first of all, before we create any course curriculum for, because quantum is a new word, chalo ek naya course curriculum banate hain and all. Very good to go for a course curriculum in your universities or in your organization. That is good to go. But what I prefer, before we get into it, let us try to understand the level of computings required. What is the real purpose of NPUs? What are the real purpose of TPUs? Where you want those, or GPUs and the clusters of GPUs? If we can solve that kind of problem from the classical model, or the level of computation you really required, think about that and that computation. So let's say, you earlier we used to call now on a very classical computing, we have CPU, we'll talk about, we have a ALU, we have CU. So you have a arithmetical logical units. So now we can say that if we have a ALU model, I think instead of taking ALU support, why don't we create a one backend, some APIs, and those APIs will transfer that computation to your quantum, where quantum we can identify. Obviously, in your academic or everybody cannot handle that quantum level of servers, very very expensive, right? Let us try to make a API and transfer that quantum computing processing part, only processing part, to the quantum in the terms of cloud. So cloud will process that part, and whatever the results being generated, let's say we'll take a web based APIs, all APIs generally. So make certain APIs, input your computation part over there, computed data to be collected from those quantums. So now the concern is time management. Now the concern is how you will handle such level of data rather than classical computing part. So this is, I believe, the way. Thank you, Dr. Amit Singhal, for inviting me, and Dr. Pawan. It's indeed a pleasure to see you both after so long. So thank you so much. I think this is what, like, the topic I have already started. So I'm just
Thank you.
in the flow now. Okay. So depending upon now the work profile, what is your work profile? I think identify your purpose of computing. I think that is what today we have to think about. Think about what is a purpose. How much data you really talk about. Shall I really give you a 9.2 petabytes daily? And let's say you collect for, first of all, do you have petabyte hard drives? Think practically. Do you really have a petabytes of hard drives in your servers or anywhere? So not possible, right? Computation. So leave computation first, you cannot store that level of data. For storage, you talk about, so what is your architecture to store the data, and what are their computational process power, and how you can incorporate in one particular task and perform that task. So try to make realistic level of, so that is what, like, we are doing such kind of experiments and research in our uh, center of excellence, where we already have, so we have certain these kind of projects for MTech students and for PhD scholars, and they are doing all these things over there. So let us try to think about, like, we have a data, and recently we have committed these kind of things where you take, like, 10 students came across, and I'll ask them, okay, how much space do you have in your phone? And let us try to be in the one network, and within the network, let us say I will take like 500 MB or 1 GB, suppose, from each device. So in other way, I got 10 GB. If 10 students are there, I got 10 GB. 60 students for each class, it means you will get 60 GB space from their phones, where they all are connected to the college network, because they are using, let's say, a college website or some app, some mobile app, some common app. So think about that way, that I'll make a some WhatsApp app or something, like any communication app or any damn app, because today you are already on AI. Now my concern is, whatever the activity being performed by them using their apps, let me collect or create the logs from those mobiles, and I will create a, first of all, a one SIM server, that is security information and event management server, SIM servers, which we are going to working on a central labs in the college or in any organizations. And in that lab, like, we are collecting that real time data from their side, from all the logs. So that is basically a centralized log servers. For that, you can use one very good tool called Nagios, or you can use Zabbix. We are using on Linux, and we are purely on Linux, and that is why we are using these kind of servers. So we do these kind of things. We create a centralized logs, collect all those logs. So we got only a log servers. That is only the logs. Think about MQTT, as I said, for IoTs, that is one of the protocol which create a one packet where the size of the packet is 2 bytes for the header and total 15 bytes of data size. So total 17 bytes packet, let's suppose. One 17 byte packet from one machine, and you have logs, say, let's say, for a longer run. So you got some corpus. That is what I said. Let us try to create a corpus in terms of various different type of unstructured or semi-structured data sets. And to handle that data, let us try to compute any problem statements. These are the big type of challenges are coming across. Now data set is somewhere else, computation is somewhere else. How's that possible? So actually, to compute, what is the best practice today? For the real-time data set, we'll try to create the clusters of the data, and that cluster transfer to a one particular cloud server, and cloud will process only that cluster and give us the results. And on that basis, we create some, you can say, a kind of index, right? So we create a term frequency or inverse document frequency kind of algorithms, or TDIM algorithms. So we try to incorporate these kind of algorithms to create certain level of index. Based on these index, now you need to which data is to be processed from which place. So this is the way today we are handling data and talking about computational model. But think about that corpus, and I cannot, again, this is again the level of restrictions. I'm already exhausted my limits, right? Now the next level is, I have a data, let's say, in qubits. So most quantum computers are large and have to be kept near absolute zero model. The fastest publicly known quantum computers are 66 qubits. That was in China, and now it's being more also. In fact, this is 2025, I think, if I'm not wrong, somewhere March or April, somewhere that time I got this result, right? And obviously now you have 66 qubits. So that is called as the I'm sorry, today my throat is not well. So this is Zhu Chong Z is the one of the 66-bit qubit, Zhu Chong Z, located somewhere in China, and they initiated one of the quantum server of 66 qubits. So qubits, like, you can multiply and you can process, and this is the one of the fastest server, which is according to the China, where they have initiated with that. Already Google also came, and many other companies has already started in with their cloud computing model. So you, depending upon how many qubits you want, they can again give you the resources. So resource planning management according to the cloud architecture providers like AWS, Google, Microsoft, and others are also providing. So already, I think, commercially available, but not even fully result generated model. It's not 100% scalable model, but yes, if you talk about soon or later, you will see within the span of 3 to 5 years or 10 years down the line, the quantum computers would be available for us for a longer range and all. So what are the various different types like quantum information science, QIS? We'll talk about. I think you can read these kind of. I'll share this PPT to all of you. According to the quantum.gov, you can just go through with this site called quantum.gov, and you will find all such details about quantum cryptography. The most important part is PQC. I think I'll give you the way. What is one small prototype program today? I want to show you a prototype of this post quantum cryptography. So how post quantum cryptography is helpful then as compared to quantum cryptography? Okay, so let us try to focus, but just try and understand what is this. So focused on exploiting quantum physics for secure communication and secure computing, that is quantum cryptography. But post quantum cryptography means what? The protocol based on the mathematical problems rather than the quantum physics, and are interactable for both the quantum and the classical computing. So today the next generational part is PQC. Really, if you want to implement and you want to make a program, and for implementation in your universities, you must incorporate how to implement PQC programs. That is that is what I said, a hybrid model of which is called PQC, where classical and quantum both can be incorporated. So cryptographically relevant quantum computers, what are these? So you can see RSA encryption, as I said earlier, also through key factorization. So there is a concept also called, uh, anybody worked on QEA recently with one of the university? We basically jointly place a one tender to Ministry of Telecom, that they already have computing, and now telco companies are working and they want some data to be for complex models solving issues and all. And we have a big challenge programs which we have to run on such a huge data set to give the results to be generated on a very higher with the fastest processing model. For that, it has been recommended for telecom organizations, and especially to Ministry of Telecom. We propose a one proper a quotation to Ministry of Telecom with the association of one of the university in Noida side. So where we compile a program and we have given to them, and that is one of the way where they were looking for QEA, that is quantum encryption algorithms, and we suggested a little beyond that as well. Right. So very simple traditional model, traditional values. So these are zeros and ones, which about decimal values. So it's a binary representation. But if we'll talk about the qubits, so quantum is like the one qubit. One qubit carries a value of zeros and ones. So it's a combination of both, either one or both. And two qubits, then automatically the range of the qubit is like increased, and that becomes, take it like a box, sort of square box. So now you have not two qubits. Two is like in front of you, it's a like front view. But take it on the 3D view and you have a like a dais where you rotate something like that. It seems to be like that. So you have two values or combination. So it is square, it is not a kind of, that is why it is called as a super values, right? Why it is the difference in that particular regard. So once you start giving a power to the bits are processing like red line, if you will see in this on the screen. So the red line is basically giving you the power that how you are going to compute. But at the same time, if you start with the quantum also, it also starts with the same way, but the quantum goes into the other way, like the level of powers and the computation will be very high. So this is how classical and quantum power per bit or qubit being represented. You can see certain algorithms why it matters, like cryptographic breakdowns occurs once you can reach to a, let's say, 1,000 qubits and all. So if we talk about AES, what is it like? Security, securing the data on the hard drives, and larger key size recommended. That is what AES. You today you are working with the earlier, DES, then it comes AES 128 bit, 256 bits, and all. Today everybody is, I think, following AES 256 bits encryptions. So the larger key, the more larger key you have, the more complex algorithms you have according to you, and you're going to secure your data onto it, encrypt your data, or transmit your data in that particular regard. This is how, like, cryptographic structured is processing. Verify your files and copying correctly between two resources like SHA1, SHA 256, SHA 512, even we'll talk about. So SHA is like for not for generally to be taken as for the data, but it is actually taken for the hash values, or for, you can say, it is for integrity checks. If we talk about RSA, so today we are working on HTTP, HTTPS. You please go and check your HTTPS cryptographic public key, and you will find RSA algorithm is there. Even you are going to encrypt your files like documents, your by data handling, or by using DSC, digital signature certificates. So how many of you really have a digital signatures, or one USB kind of a token which carries a DSC, and to sign your tenders, or for invoices with PSU, we have to make that document digitally signed, right? What is the algorithm behind DSC? Again, RSA. And take my words, RSA is no more secure if you really go and compute it by quantum. Because what was the challenge? The challenge is only the time processing on it. And today, time is not, its parallel multiplication of the processing is going on, which is quantum, nothing else. Like, this is the way how it works. So even ECDSA or ECDH algorithms used for digital signature algorithm, DSA algorithms, but again, all are not secure at all, because these are the algorithms, and all these applications are about to be obsolete because of quantums, right? I hope this concept is quite clear, like what is, why the things are going and getting into it. So I just want to show you something live. Shall I show you live something? I think would be better, Hannah. Let me let me talk, and I'll just give me a minute. I'll show you a live, something live, so that becomes quite easy for all, to make it more practical. Whatever we are saying, I think this is not a day one. And what is quantum? I think you are now quite aware of these basic things. But let's say I'll try to make something good for you. Just give me a minute. Okay. Yeah, I hope again the screen is visible to all. I'm talking about like small modules. I have divided my sessions actually into the multiple module. So the first part, which I was more talking about, classical computing, qubits, quantum superpositions, right, and various other issues like quantum measurements and decoherence. So how you can measure and how you can split or work on decoherence models and all, or computing architecture like gate-based quantum computers or quantum annealing, etc. These are the areas which is the basic quantum functionals. So let me try to take you to one of the experiment on that. Now, what is this all about? If I'll quickly explain what is we are actually talking about. So if we talk about, like, one of the again part was a decoherence. So quantum systems are basically a kind of a fragile model. Try and understand now what is this all about. So decoherence and noise limit is the current limits the current system. ये जो अभी like you are working on whatever the system we are talking in the quantum. So this is again one of the challenge that this quantum systems can be fragile, can be isolate, or can be splitted, or decoherence or noise limit current systems, we can say that. So there is a limits in certain things, which that is why, like, we used to talk about the hybrid classification quantum model, because everything if you will give to the quantum is not good to go, because then it would be spread across, and sometimes the anomaly results being generated, false positive results being generated, that also been identified, because you have one of the data being processed in another qubit and other is going to be another qubit, and then the result is to be identified, and that becomes a really a challenge, because, and that is why I told you the initial ground, the isolation process of the initial stages need to be catered on a classical form, and each cluster need to be simply processed by the qubits, would be really helpful for you. So that is why we have to talk about like hybrid models. That is what I have just tried to explain you how the things works on a various different models. So for if we'll talk about cyber security perspective, so takeaway it is simple for quantum computing. Don't take it as a fastest one for everything, right? Fastest for computing is different, but for data handling, collection, processing, everything is not with that particular part, right? So quantum have the specific purpose as compared to the classical one. Okay, so everybody have their own. That is why I explained you that you have to define what is the kind of a task you want to perform from which kind of processor, and then you talk about that level of computing would be really beneficial for all of you. And then that is one of the very classical example in security cryptography. That's what I have explained you all that stuff, right? So what are the threats for cybersecurity? That is also being covered, as I have shown you what are the common threats for cybersecurity. So I'll take some small case study that how we can talk about, and that is why cryptographic assumptions in the current system is a one of the part, right? What are the assumptions in terms of cryptographic assumptions are, what are these assumptions all about? And as we talk about Shor algorithm, like I think everybody was talking about Shor algorithms, and that is why I had given you the co-relevance with the Shor with like RSA. Because of Shor, it was clear impact on RSA, ECC, and digital signatures, right? Grove algorithms were actually going to work on AES. So that is on symmetric encryptions and all. So you have Shor and Grove, two different algorithms for asymmetric cryptographic models for digitalized, digital signatures, or anywhere where you have a asymmetric and unstructured or that kind of data set. And with the unstructured data set, you're talking about public-private key. So this public key cryptographic concept is again into the challenge using Shor algorithms. Okay, but if you talk about symmetric algorithms, so various different like AES, as I said, and various other AES algorithms are there that could be again harmed and to be impacted by Grove's algorithms. You can go through with the Grove's algorithms, and that is the way how it works. So what is the best practice? Harvest now. That means you divide your data and process that data and collect that data now, and then later we'll go for the decryption model, right? So attack later. So this is a one small statement where today hackers are following. Let's say we'll try to collect the data, harvest the data as much as possible, because afterwards we can simply decrypt or we can further process whatever the things required. And direct risk, obviously, if you talk about digital signature, which is a part of our IT Act, which is a part of our e-governance model, in fact, I would say the direct impact goes to BFSI models, that is banking and financial services, insurance services, even your data, which is to be processed by cloud computing, your username, multi-factor authentications, where you are using certain algorithms can be easily cracked down, and obviously a big risk for our national infrastructures, right? It's a critical infrastructure. There is a department called NCIIPC in Government of India, who take cares with the support of NTRO, and NCIIPC, who take care for cyber related threats and cyber related data infrastructures. And I was in one of their event. I was a jury over there. I remember with the collaboration of IIT Delhi, we performed one of scython, like a hackathon sort of, but we gave the task to the participants, and these participants perform those tasks for securing NCCIPC projects. So that is one of the project where I was a jury over there, and I identified like things where this NCIIPC is one of the game changer for Government of India, for Indian context, right? Okay, so let's say, and then we'll talk about PQC algorithms and all. Okay, let me take you directly now to the yes. Just take a look. I have a small practical, some implementational models for all of you. And to get into that level of implementation, I'll take you to, yes, this one. Okay, yeah, this one. Okay, so just take a look. I hope screen has already shared, and now you can work on various different models, and you can understand how qubits are working and everything, what is superposition. So already I discussed these things to all of you. I want to take you to one of the practical. Okay. I already started yeah. Can you see the screen? Is it visible? Yes, is that visible? I don't know. Can you please check? I shared the whole screen.
So your screen is visible.
Okay. And this Jupyter notebook, and this is also visible?
Yes, sir. Yes.
Okay, okay, okay. Perfect. Fine. So, well, I have some labs for you. This is my lab one. Just take a look. I try to make certain labs, some projects, to understand how things works. First of all, if we really go and get into this particular project, so I'll take you first project, and I'll show you what is this all about. This is a program where I'm talking all about in this way. I think that's better, right? This is cryptographic inventory discovery using AI. A simple way how you can classify your data, as we are talking classifications and all, but how you will manage the classification. So please don't take it as a real time practical of quantums, because obviously it is very, very expensive. Even you go with the cloud, and you need a proper setup, but I tried to use with my CPUs and just try to give you the feel of quantum. So that's what, like, why we are working for quantum, and what are the real time initial level of challenges which we are supposed to work on quantum. So I have some small prototype which I want to explain to all of you, and to just to show you the things how it works. I have a small target first lab, that is cryptographic inventory discovery using AI. There we have some source where and some configuration files. So what are these configuration files, why we are learning, why we are getting into? So I just show you that data as well. So I have small, very, very small data set, even not a proper sample size, less than even a sample size. But this is just for your testing, and to just to make you more comfortable about some computing powers and all. And I'm trying to incorporate like machine learning and some AI part with quantum, and with Python. So it's like a hybrid sort of model, right? We are trying to detect the cryptographic algorithm and the keys from some data set. Now, what is the way? How many of you really heard about ransomwares? I hope most of you have heard about. And I don't know if you are a Windows user. Sorry, I'm not a Windows user. You can even see I am more on my system. And this system is nothing, this is my operating system. We are the India's first company who designed the Indian operating system. I filed patent in 2011. So this is my company's organization's operating system, Sedulity OS. So I'm working directly on these kind of areas. So just want to show you, I started with my Jupyter notebook. So this is just a basic Jupyter notebook which is there, and where I just started. And this is what a small program, some collections are there with the in the quantum cyber and AI with the combinations. And I have some data set for you. Okay, now what is this all about? uh, why we are trying to identify the algorithms and the keys? The concern is, like, I have a data, and we have a quantum risk inventory reports. Now you think about like various algorithms. Means I was working with NIC, one of the server, and I remember we got a web shells. And long back, in fact, if you remember, I don't know you heard that part or not, but if you really go and check, you will see the CBI site was hacked long back. I don't know you remember that or not. CBI site got hacked. And that CBI site, why it was hacked? Because we got some sample in the web programs. So it is basically a shared server where CBI site was there, and actually CBI site was not hacked. One of the another government small project sort of from different department was there, and somehow their pages got compromised. So that was a direct web application attacks implemented by using RFI attack. Actually, RFI is basically a remote file inclusion attack. And through that, what they did, the basically hackers tried to incorporate some blank files of PHP, and those blank files are like where they have some method. And that is a kind of a concept of abstract methods. Hope you heard about abstract methods in Java or various other resources, right? So it is a kind of abstract method where the content, the code has not been incorporated. Only the name of the method is there, and whatever being, you know, imposed by the server, and that API is to be get executed. So that code get executed on the server side. So some abstract methods, some abstract PHP files and abstract methods identified over there, and some encrypted shells identified over there. where some keys are there. So I'm talking about server side, right? And just because of that, now hackers try to explore through those shells and they get into the folders. And once they get into their folders, they start exploring the site. And luckily, they found CBI site. And so what they did, they didn't target to the site from there where they entered, but they target CBI site and they just replace their home page with their page, and then the page of some Pakistani flags and Fateh and blah blah things were written, something like that. So it was defaced for a couple of hours. I was with then certain, so I was a consultant at that time, and supported to certain with their all the senior scientists. And then we explore and we got our files and we explore servers and we got that content. So basically now the challenge is, you because you have a huge data, petabytes of data, as I said right away to you, right? 9.2 petabytes, suppose, where each file of 17 bytes, and then you have a petabytes. Can you able to identify which file carries which algorithm, or any particular key, digital key over there? See, I'm taking you on a very deep dive on a different level. Try and understand, so then only you can able to understand these kind of problem statements, okay? And I would like to make you more comfortable. And why should we go for PQC algorithms? That is a post quantum cryptographic algorithms, and especially for PQC, migration is also one of the another level of challenge. So I will take you into the various different resources. So first, try and understand what the problem statement is all about. You have a data set, huge data set, you have a complex models. You now we need to, let's say somebody is trying to apply now ransomwares. What are ransomwares? Quickly, I'll just talk about very brief. And to 2016, it was introduced in 2017 April. It came to India also, and various machines, especially Windows machines, got hacked with these kind of certain attack, WannaCry, Petya, not Petya, and many more ransomware introduced in India. Banking system got already a fear factor, and many more things were there. Now, what is the concept behind ransomware? Especially, ransomware is a special kind of a program which comes to your machine via some third party links. So somehow you clicked on some third party links, and a backdoor server connected with your machines, or some backdoors initiated, some backdoor application deployed in your systems. And now those applications were trying to identify the data files, where the data file extensions are PDF, docx, xlsx, txt, jpg, png, all multimedia data files. Wherever they find the files, they apply some algorithms, again in cryptographic algorithms. And these algorithms will going to pick a file, apply a cryptographic algorithm on that, encrypt that data, and save that file over there only, with the renaming, with their extension and whatever they want. So there are very much random extensions of those files identified, with the same initials of those file along with their extensions. So that was the culture, like a ransomware came. And afterwards, once the process completed, so they basically try to identify their data files. And as they found data files, they pick those files, apply algorithms, encrypt those files, and make some changes over there. Few of the ransomwares keep their decryption key within that system only, right? And a few of them, they don't. They have some API sort of. So these are the areas how ransomware is increasing, and they augmented their behaviors and their activities. Now what happened? Now if this kind of thing is happening, my concern is, quickly, how much space, how much data, like you have a 500 gig, 256, 500, 1 TB, 2 TB hard drives in your laptops, in your computers, or on your servers. And if you have a data file and some algorithm is processing, something is going on. My concern is, can we able to identify the algorithms where are those algorithms, and can we identify the targets of those algorithms? And that is the risk area, because two things: now you are applying cyber security algorithms, cryptographic algorithms for ransomwares. Second option is you're using cryptography for data security. You yourself encrypt your data for data security in such a way that you want to keep that data, and the data should not be leaked out. So that is all your purpose. Ultimately, there is an algorithm. My concern is, if I want to make a manual ransomware mitigation model, how you will initiate? So can we identify some keys? Is there any key available in my system? What are the name of those files? Where are these keys? Where you have a cryptographic models or any algorithm name or something, or can we identify those things out of it? It's like a searching model. It's not a very big, but the purpose is to scan the source of the file and the configuration files, detect the cryptographic algorithms and their key and their key sizes also, classified them as a quantum vulnerable or quantum safe or needs migrations. So now you will, I think, able to understand this statement, what I was actually trying to pinpoint. What is quantum vulnerable part? What is the security part? Somewhere both way, algorithms are cryptographic algorithms, right? And need a migration. Where you need a migration, what type of migration you want? You want a data migration, you want a data security migration, you want a algorithm migration somewhere. So that could be any type of logic which we can build up. But for that, what is the best practice for today? Are you really going to do a searching? Like in Linux, you have a concept called grep command. Are you really want to do that grep command? Today we have the option. Already we have the option. We can go with the grep command, right? Grep and then patterns. You can search in the entire hard drive, but it processes one by one. My concern is I have a data like in petabytes or exabytes. So small computing, classical computing creates the limits at this stage. And now I want to incorporate, let's say, AI on it. So I want to create a model, machine learning models, and let's say poisoning machine learning models or adversarial network models that are again the big challenges where we can talk, so there are some, let's say, basic AI models. I want to build a one AI model, and that AI model need to identify some data, and based on that, some rule based or generative AI models need to be incorporated with some automation. So I want to make a AI agents, agenting AI or AI agents, hope you heard about. So we are going to talk on that level. For that, what I need again NLP. I need lightweight machine learning structures, right? So that all can be incorporated. Is it possible? So I hope now my problem statement is clear to you. My purpose is to just to give you a problem statement for research work, and then you decide how you can take them into a research for a PhD level or research level. I think would be really helpful for all of you. So cryptography, inventory discovery using AI. I hope now the objective is quite clear to all of you. Automatically discover the cryptographic usage in the applications and generate the quantum risk inventory report to support post quantum cryptographic PQC migrations. So the purpose is to implement somewhere PQC migrations, but for that I need a report, that is a quantum risk inventory report, which it generates, and it basically try to perform. So for that I have the code. Okay, this is how. So what is the structure? I am into already into the lab one. You can see lab one, crypto inventory. I have a one folder sample code. Let's say I have a sample code where I have three files. One is app file, could be any Python file, could be any YAML file for configurations, could be any conf file for security, or a multiple files, let's say, where we have some sample code of a program or some software or something. And for identification, we have a crypto inventory.py file, where this file will go and get into this machine and identify the process and generate a report. The report, nothing but quantum risk inventory report. So that is, suppose the target is to work out and to incorporate the things. From where I have a lot of cryptographic libraries which I try to import in Python, even importing from RSA or EC algorithms, and I try to generate RSA generative private keys, and where public exponential keys and key size is 2 kilobytes of RSA key, where I have some variables. Let's say we'll generate the key, and that key somewhere kept in some file or mentioned somewhere some in some files. So let's say this is what the program which I mentioned in some code, that is app.py. So understood what is this app.py, which says that I am going to generate some RSA keys. So it is written somewhere in the form of coding. Apart from that, I have a one config.yaml file, so you can read and you can go through one by one. In fact, you can take a look. I have a sample code, and this is my Python. This is the code. Hope this code is clear to all. This is app.py, from where I'm going to supposed to talk about, like I'm talking about RSA, I'm talking about a key generation, how much key size, and various other things, or why not EC algorithms to generate a private key and something like that. Let's say I have a one configuration file. So this is just a sample, even not a sample. Please try and understand. This is a small prototype where I wrote some encryption algorithm YAML file. So I want to apply AES with the key of 128 bits or something like that. And I also have a one security.conf where I mentioned that TLS RSA with AES 128 CBC SHA need to be implemented. This is the direction which I have given somewhere in these three different level of files, which is nothing but the sample code is there, right? I hope this part is clear. Then I'll come to the queries, because I'm not on the screen where I can see your queries, so I cannot see your chats. Yeah, fine. So, but that's what, like, I just want to produce like what the things I'm practically implementing and something like for you. Apart from that, then I have a one requirement program. That means, let's say for handling a data, I need a pandas. That is only the library which I'm going to use, and this is all what my code is all about. I'm using OS, I'm using RE, I'm using pandas. Very, very simple. I'm just trying to make you the just to give you the culture, what is quantum and how it is going to help for PQC migration. Why PQC and what is PQC? Why PQC migration is required? What is the purpose? But at least you should try and understand. This is a small code where you are understanding, like, so probably you have some crypto databases, like we have RSA, ECC, EC, AES 128, 256. So you are getting some keys. These are the keys which are lying somewhere with their types, with their vulnerable part, quantum status, and all that stuff. We have a pattern. So in case if we found something like that, could be understand like a patterns. And further, we are going to scan the files. So Sochina, what is the best way? How ransomware works? They also do the scanning of the files. How security works? Like an NIC server, we try to identify those files. So we also try to make some scanning of the files in their entire server's drive, all their web servers, and we found some web shells in some other website, but they hacked other site because it was a shared server. Understood? So challenges and concept is saying like scanning the files. So what all you can do, you can, like, say, go from the root architecture, the path where you want to run the program. So from where you are running, this is the current path. We'll take that path, we'll join that path and pick that part. If file, make it readable. Errors, obviously just ignore the errors. In case if you're not able to read the file, then what happen? Suppose you have some system files or various other binary files. So if there is a error, please ignore and just continue further. Whatever the files are possible, you could just try to read the content and try to categorize the results in some parameters like file, algorithms, types, and quantum risk. And whatever the pattern you identified, just go for append. till the time this loop will not finish, the process will not finish. So you just continue with these kind of things and generate the exceptions, special exceptions on that in case if certain exceptions are there. So runtime errors we are handling. Okay. Risk classification. So AI algorithms, again, if vulnerable, then it is high. If it is weak, then medium, otherwise low. So we try to create the level of severities. Okay. Classifications of the risk based on the level of severity, high, medium, low. Even you can add critical, you can add informative. This is what generally we used to get in VAPT reports or many vulnerability assessment scanners. Okay, so there you will just do this and you will get us some part. And the main program is, we have a main program. Let us try to collect that data. That is why we just use pandas. And if everything is done, we have a DF in the form of result as an object. And if DF is empty, so no cryptographic algorithm identified. But if it is identified, then generate a proper report in the proper model and save that report into CSVs. Let's say we'll transfer that data finally to CSV file. So we got our Excel sheets in the form of it, or form the reports. I hope this program is a very, very simple program, but I want to make you just to give you the idea before you proceed to QAC migrations and all, what type of applications we need to execute and what would be the expected results. Let me take you and run this program for all of you. I'm already in the folder. Okay. I hope there you will see I have a folder where I have some files. You can see these files and folders which are already there. I need to install all the requirements. So I have a pip install -r from the requirements.txt. What is the requirement? I have only pandas as a requirement. Okay, so I am just going to take you to that command. So pip install the requirements and just press enter. So already panda is there, so already satisfied. Program is good to go. And finally Python, I will run this program called cryptoinventory.py. Right? Let's try and identify. So just take a look. I got some report. This is a cryptographic inventory report. You got a file name, you got the algorithm, you got a type, you got a quantum risk and risk levels. So as I have shown you, app.py file, which was in the sample app.py file, that includes two algorithms, which are somewhere mentioned, two algorithm. One is RSA and second is ECC. And both are vulnerable with the high risk. Same way, I have one more file called config.yaml. In config.yaml, we have a AES. I think if you remember, I'll show you again. See AES 128. This is config.yaml. And what is the report? Config.yaml identified that they carries the AES 128 symmetric V quantum and medium level. So can we figure it out, like what are my targets on the real-time data resources, on my clustered resources, on my isolated resources? So today there we are talking about, and accordingly we need to generate the cryptographic algorithms and the inventories where we have the files, and these files are going to implement the cryptographic algorithms. Why not we can target now ransomwares in this way? Why not we can target some attacking files like RFI attacks, or as I've told you, one more application of abstract methods using in PHP process, especially for server hacking and server APIs, token hijacking and all that. So I hope this concept is clear to all. What is this model all about and how we can figure out the things, where I have right now only 3 files, But think about 3 billion files. Then what happened, right? And how you can identify and target what we are supposed to do for PQC, let's say migrations or other activities. I hope this concept is clear. Any doubt at this stage? How to proceed? Great. Thank you, Dr. Singhal. Thank you so much. I think what are their targets? Why AES quantum attacks or RSA algorithm vulnerable, and can we able to trace it? Can we able to identify it? So post quantum migrations, how we can prioritize to that particular part. So that is the whole sole purpose of all about. We can try and we can talk about another more practical, another good practical, like what is PQC. What is the concept of PQC now? Because every time you are talking about PQC, so let's go and get into the PQC model. And why I suggested PQC, because it is a kind of a hybrid model, and for that PQC is a far better one, because we cannot switch directly to quantum, we cannot sustain on classical computing. So let's come to the PQC algorithms, how it is going to refer and helpful for us. So PQC cryptography refers to the classical cryptographic algorithms run on the classical computers generally. So this is post quantum cryptographic model, right? And that are resistance to the quantum attacks and do not rely on the quantum hardwares. So the best part of PQC is we don't want computers like quantum computers. You can run PQC, okay, you do the processing, because whatever the processing being committed by the quantum servers and result being generated by the quantum servers, afterwards we want a classical models. We want post quantum cryptography implementation, and for that, what is the best way? Again, we can simply run on the classical computers. We are again we are resistant to the quantum attacks, so automatically we can understand what all the applications are attackable according to the quantums. We can identify, and then we can make it more target oriented, and we can upgrade, we can launch a new versions, we can I think we can go for the mitigation as whatever is required depending upon the applications or the services using. And in that way, again, already we are ready to go, because we are already having and equipped with the classical computing models. So already it is there, already we are working on it, and we don't want quantum computers for that, but the quantum need to identify and generate the reports. Report comes to us post quantum cryptography. We use classical cryptographic algorithms, and for that we don't want quantum hardwares. And the purpose is what? Already, Shor's algorithm and Groove's algorithms I have already explained, and many of you already, I think, gone through with the Shor algorithms and all these algorithms. So if you are already through with these algorithms, how can you mitigate? Think about the way of mitigation in terms of security from these algorithms, where already we have various different resources, and think about the challenges which we are working. So try to create a resistance to Shor and Grove's algorithms. Compatibility with the existing networks, obviously you have to think about, and scalability, performance efficiencies are the major targets on PQC model. Why PQC? I hope now the purpose of PQC is more clear to you. So that is a small experiment which I tried to show you, that we have some centered data and the process, and we'll try to figure out the content from that part. So major classes for post quantum, you can try these algorithms. Lattice based cryptography, certain post quantum cryptographic algorithms. What are the major classes? Please note down, and I think if you want, you can apply and you can implement these algorithms. You can think on crystals, kyber, that is key encapsulation model, that is called crystals kyber, is the key encapsulation models, because keys are the target. And now my concern is, can we encapsulate the keys? So understood how I identify the keys, AES 128-bit, AES 256-bit, and all. And so purpose is, you can try the lattice-based cryptography model, and crystal kyber, that is nothing but the key encapsulate. Let's try to encapsulate the keys. If the keys are got encapsulated, or in somewhere your digital signatures need to be encapsulated, but for that, what is the best practice? Now we need to upgrade our digital signatures by, let's say, crystals dilithium. That is dilithium. The crystals dilithium is the another way where we are targeting to secure our digital signature projects. So did you ever thought about, like, what all the next level of algorithms being introduced for mitigating and to encapsulate and talk about digital signatures more? Hard lattice problems, learn with the errors. Obviously, most of the hackers are learning from errors. They need to figure out the errors, they need to generate the errors on the servers, and once there are certain errors, according to that, they will get the footprints, digital signatures, and various other information about that servers and that uh, application or their resources. Same way, we can go with another model, let's say adversarial networks. Go in adversarial, reversal model, adversarial models. You can apply even those algorithms if you want to apply. Learning with the errors, LWE, that is a hard lattice problems, and that is for the security basis we can work out. So what would be the advantage? Strong security proofs, efficient key exchange model, and the best part, widely adopted by NIST standards. So please make sure compliance issue is the another challenge. Today, you and me can sit together and make any algorithm, but that algorithm is really compliant to the worldwide standards, Web 4.0, 5.0 model, industrial 4.0, 5.0 model. Think about that. Think about infrastructure, critical infrastructure compliance issues. So you cannot create new algorithm by your own. Even you can, I'm not saying that you cannot, but my concern is, what about compliance issues? So think about, how can you control that compliance, how you can mitigate those compliances issues and risks and those challenges to be synchronized. And why not NIST standards to be get synchronized? And that could be the advantage if you go through with the post quantum cryptographic algorithms. So this is one of that, lattice based cryptography. Try the lattice based cryptography algorithms and try to implement that, right? Another is hash based cryptographic algorithms. So hash based, SHA, generally hashes we generally talk about. So some more example, like XMSS and SPHI NCS plus as some cryptographic hash functions, so that your hashes not to be disclosed, or should not be. We for securing the hash, what generally we used to do, we go for a salting, salt hashing, and we have that kind of concept. Generally this is how we are doing, because there is a certain patterns. If your application is based on salts, or on your regular hash, let's say SHA 256 or 512, hardly matters, because if I'll get one data set, a pattern matching technique, I can retrieve the value whatever being stored through those hashes. Especially your operating system passwords. How everybody hack the operating system passwords? Your Windows, your Linux, your Mac OS, all have some algorithms, and they have their data stored on certain files. Like in Windows, you have some specific file like SAM, hope you heard about, right? Where you have the files, your passwords, and those to be. So we want SAM Hive files. Hive files are there in case of Windows forensics, we used to take those SAM high files and extract the passwords from that. So password extraction applications build on those models. But generally it is time taken process if you want to extract, because it is a hash itself is a very huge hash, and you need to create a patterns and you need to match or correlate and many more things. Again, classical computing. But if you go take it to the quantum, then it is very easy, because that computing will solve your problem and figure out the data and retrieve the data for you. So what is the next level solution? Can we think about a hash-based cryptography using some more examples? Or again, this domain is still open. Propose new algorithms which are dynamic hash. Have you heard about? I don't know whether you really work on that, but if you are a research scholars and you are really thinking about it, then think about a dynamic hash models. Dynamic salt hashing. So I'm not creating a standard values like MD5 always create 32 letters, right? SHA1 creates always 40 letters. SHA256 creates 64 letters, and SHA512 creates only 128 letters of the key. So the key standard is fixed, size is fixed. My concern is to make manipulations. Today we have a solution like salt hashing. We used to talk on those algorithms. Remove salt hashing. Again, it is quite identifying, means quite possible to identify the salt hashing, because then again you have some patterns over there. You have a common static model, some method being imposed on that hash, and by using quantum we can again, now we have a good computing power. Please try and understand. We want to make it somewhere, some stage of impossibilities, right? Inaccessibilities. Think about those models rather than computing model. RSA always works like high computation required to decrypt her. That is why RSA is no more, right? Try and understand. So RSA is about to be obsolete, right? So today we have to think about inaccessibility. We have to think about impossibilities, incompatibilities, in compliance creations of the high algorithms, cryptographic algorithms and all. And for that, if you work, let's say with the hashes, hash where you have salt hash also have some patterns. If that pattern's identified, your salt hash also being broken up, then what else? What else? So we want strong hash-based algorithm. Think about dynamic salt hash. Think about XMSS algorithms, or some, this is what being proposed generally, SPHI and NCS plus algorithms. That is hash-based algorithms only. But think about mathematically, or somewhere we can create a new model, a new hash algorithm functions. Understood? Like, what is the real way of implementation? Large signature sizes, obviously that is a limitation. You can say performance overhead and all that. No. So third stage, now another third stage for PQC migrations, and the goals of PQC. The first, as I said, various algorithms are there. First is lattice based, second is hash based, and third is code based. Now for code based model, third stage is classic Mac Alice. What is this? Error correcting codes. So find only that particular error correcting. Like I'll just give you a sample. Find the algorithm wherever it is readable or accessible. You will get a target files into the entire corpus. Simply pinpoint to that stages. Apply your methods and make it more secure from quantum attacks. Understood? From the quantum attack. That is what like the purpose is all about. So for that, we have to go for a reverse engineering model, or adversarial models, or as a error coding models, etc. Decades of cryptanalysis resistance. So that is what the advantage is, that cryptanalysis won't be, it resists for a longer period, and that would be an advantage for securing your data. But extremely large public keys, again, we try to solve one problem statement, we actually stuck on the other stage of the problem. That is a realistic problem, because I'm a practitioner, and that is why I'm saying you, uh, I used to, I'm not a theoretical only person, I implemented most of these things, and that is why I'm telling you, you try to solve one problem statement and you will find one more limitation out of it, because these limitations are going to generate another challenges. So the moment you make more complex, more code oriented, then automatically the large public keys, just to save those large public keys, again you need a big data servers. Do you know this? Means petabytes of data, and each file, if I want to encrypt, and they carries their public private keys and public, where you will save these keys? you know Already it is difficult to save the data, and now, unnecessary overhead, that you have a large public keys. Do you really believe if I'll make a large public key for your HTTPS website, are you really going to open those websites easily? Today your web pages are generally in KBs, almost, even you reach to some MBs. But think about, if your web page is of 800 MB, 900 MB homepage, how you will going to open those websites? Because the huge data, and then for that you have isolations, group, object orientation. For each object might be you are implementing some algorithms, as and when required you are opening it. Again, we have to think about how you make a UI UX model for that. A good challenge, है ना? It's a good area of practicing, but yes, you must try and you will find something more solutions, I believe, because depending upon application to application, that problem varies. So again, our application must be isolated also, and it must be area specific, where you are implementing the code based cryptography. Then only your quantum will not able to analyze it. And let's say if I'll keep keys on a separate servers, I have only a separate dedicated key servers, and I have a data indexed. So I have an index server, I have a key server, I have a data file server, and that data was already split it into various clusters. Now you think like that kind of infrastructure, then how you will handle it? So large, high, complex model means, today we are talking, please try and understand the problems where we are actually landing. Today you and me do not have that data set. So it means we are talking for a big giant data sets. Think about Facebook server, think about Google server, chat GPT servers, lots of LLM models. Think about huge servers, huge big servers, big data. That's why I use a word called big data. Concern is, very soon you will see that level of data need to be handled by you in your organization. First it comes to your organization, and then slow and gradually you will be fully equipped with IoTs in your home, in your residence only. Today you please go and check, probably you have 8 to 10 different Wi-Fi devices at your home. So in other way, you are running a one cyber cafe in your home only. You have 4 5 means, if there are 4 people, then 4 mobiles are there, one television might be there, one laptop might be there, so 6 7 8 devices are already there. And if you have CCTV cameras, or multiple TVs, or multiple, or even you have a smart watch, or you have a IoT like gadgets, then it's a big list. I'm talking about journal. So you remember, we came from a cyber cafe stage. One cyber cafe means 4 5 6 10 computers, and at home there was no internet. That was a case, just go 10 years back, 20 years back, 15 years back, you will find automatically that stage. right? So we got a cyber cafe. People used to go to cyber cafe to take the printout, to check the mails, to process or social media, etc. Because we don't have that level of internet capabilities. Today we have that capabilities. That is why every home is a cyber cafe. Every home is a cyber cafe. Not organization already equipped with the hundreds or even thousands of digital gadgets. And what is the next generational? Next generation is your Facebook data set would be there in your organization, because how many students are there in your college or your universities, and you want to handle their social media, you want to handle their devices, their gadgets, their blah blah blah, many more things which you need to be incorporate in your organization. Then you automatically becomes a one big tech giant to handle that level of data set. Stages. We are coming to the next level of stage, and get ready of that level of stage. Researchers started working on identifying the mitigation policies and the algorithms for that is what our job. And the futuristic approach of quantum computing and quantum securities, right? Multivariate polynomial cryptography. One of the thesis of my scholar was polymorphic shellcode detection technique, and we try to mitigate by using some blockchain technologies like Ethereum, and we implemented a one solution so that untraced malware, untraced polymorphic shellcode can be identified. It's been so long. You can find the same thesis available on Shodhganga. You can find my name, and with my scholars names you will find one more thesis like that on this particular part. So multivariate polynomial cryptographic solution, how to solve the systems, a fast signature generation model. We required multivariate, so automatically you have a multiple variables are required. Multivariate polynomial cryptographic techniques are required, and that to be a dynamic layer where you have a dynamic parameters, right? And on that basis you talk about a fast signature generation model. Some schemes broken into the early rounds, so certain challenges were there, and we need a careful selection of the data, whatever the data or the parameters are required. Compliance of each parameter, in AI ML, you selected multiple parameters, and out of that you select what are the relevant parameters, and then only you do the computation for that. Rest of the parameters you simply ignore or leave it. So that is the again common same problem, same statement for multivariate polynomial cryptography, to solve, to go to the PQC migration level. What is PQC and why, and what are the four different categories of cryptographic algorithms for PQC? Is that concept is clear? Why we are supposed to go and get into it? And if it is okay, then I would love to share mm, another program for all of you. I have a one more program. Let's say we'll try to go with another one. I have a PQC recommendation. I have various other. I have one more hybrid cryptos. So hybrid classification plus PQC encryption. We can go and create like these kind of algorithms, and small demonstration is ready for you where I can show you how we can make a hybrid crypto model where we have some predefined constraints or some data sets, and based on that, let's say, try to create some results. Is that clear? Meanwhile, I think, is there any query? I'm also yeah, I hope now you understand what is PQC and what is the real purpose of PQC, where we are taking these things all together, right? थोड़ा ज़्यादा intense तो नहीं हो गया technically? Everything is fine ना, है ना? Because see, actually I used to practice all these algorithms, and we have given these kind of demonstrations to some government bodies, some ministries, and they really appreciate these kind of areas, and they want, okay, what would be happen and how to handle such problem statements. So that is why I'm just going to discuss some of that with very, very general terms, very, very general terms, right? But think practical issues. I'm actually working on real-time data analytics and data handling, data security. So these are the areas where we are focusing. Still, you face any inconvenience, so please let me know. I'll discuss the things on that ground then. Let us take you to the another practical. Want to see the another code, another practical, how we can go for it? Great. So just take a look. Uh, Another one more example which is ready for all of you, that is related to hybrid classification. That is a classical hybrid classical plus PQC encryption model. So how to go for it? Classical cryptography, you know, RSA. So that is a classical one. But post-quantum cryptography, why not we'll go with a Kyber simulated or library-based data sets. So this is a Kyber. I told you, I have just explained you this word and this term, how you can go for the Kyber-based algorithm. So final, we have to the session key is derived for both the keys, ensuring the security against the classical attacks and securing against the quantum attacks. Okay, so how we can go for it? Because just try and understand, if you implement quantum for your application development or computation, hackers will also use the quantum for hacking those applications. So very simple. If you are on a car, if you are going to drive your car on a very high speed, and if we have to catch you over there, again we also have to be on a car, or again more faster vehicle than your vehicle. Same way, same policy. This is, chore police game. That would never stops. So conceptual flows. What is this all about? Let us try and understand. We have a folder. Let's say I have just a one hybrid folder and small code with small program. So I'll just show you. In this program, I'm using a cryptography or PQ crypto library. Understood? Two libraries I'm using. One is cryptography, another is PQ crypto library. So you must try PQC, that is PQ crypto library. And let's say we'll have a code. And in this code, what we are supposed to do, PQ crypto library is not available directly. So might be your system fault. So please check, right? Provide a fallback simulated PQC approach below. So how can we get into it and just take a look? We have a code from cryptographic, Hazmat, primitives, asymmetric, import RSA, comma padding, then you import hashes, then you import cipher, algorithms, mode, then you import default backend and serialization. Because we are handling on operating system, where you need OS and hash length. So I think these are the common libraries, but these are the basic. But for cryptography, the library from the cryptography, you need to deploy the things. You need two major requirement. One is cryptography and one is PQC cryptos. Okay, so one classical program. Let's say we'll try to pick one classical part. Okay, before that, optional. We'll just kept that on optional part from pqcrypto.chem, that is Kyber 512 algorithm. Let us try to import and generate the key pair encryption decryption algorithms. And we define some variable pqc available equals to true. Okay, but in case if there is an error, if this library wants support or this method, today it is working fine, but tomorrow might be deprecated, any method deprecated, or any challenge with this PQ crypto, then in that case, then PQC availability is false. So we need to check whether PQC availability is true or false. For that, as I have already the content, let me take you to the folder. Okay, so we are now You can see now I have a folders, right? You already have the requirements you have seen. I have a two major requirement, cryptography and PUQ cryptos. And let's come back. So let's try to install the libraries. So PIP, PIP for Python, install all the libraries. Already satisfied, already PQ crypto is there with me. In my data set, I'm using Python 3.11 actually. So make sure you need at least Python 3.9 or above. Okay, that's a basic part. And afterwards you can run this because otherwise you might face some challenge to run. At least Python 3.9 or above. I have 3.11 right now. And that is why I'm able to run this library, right? So everything is fine. And let's try to run a code. Hybrid crypto.py. Okay. And say we'll just run this code. And can you imagine, can you see this part? A wonderful part of this hybrid classification plus PQC encryption demo is there. Classical RSA algorithm establishment, PQC shared secret establishment, and a hybrid session key drive, that is AEC, AES 256. These are the three major things being identified. And encrypted message. What would be the encrypted message? Did anyone seen such kind of code? I'll just zoom it for you. Yeah, just take a look. Did anyone found any such code in your programs? Or these are the shells I was talking about, NIC server, web shell. That web shell contains similar like of data. And it took a lot of time to identify what type of data is that. Base 64 in PHP, base 64 encryption algorithms we use generally, base 64 in PHP. If you know PHP, right? But obviously you can decrypt. My concern was like, if it is something different, and what is this shell all about? What is this kind of a content all about? And do you know what is the decryption message using PQC? This PQC extract the data out of it in front of you, and that says that quantum safe communication using hybrid cryptography. That is a message. So hybrid encryption successfully done. This program is successfully executed. Right, this is a small set just to show you there is a code, there is a such kind of code. Anybody identified such code in the web shells? I recommend, if you handle a web servers and your websites are on PHP, and especially if you are using that WordPress, which is more hackable actually, or any PHP common CMS, common that is a content management systems. So in case if your websites are on that, make sure what you need to do, go and identify this code. These kind of shells are important. Please diagnose and identify the shells in those files. So now what you need to do, you need to do the first program and the second program in combination. Run these two programs, and because PQC is post quantum things being done, committed and all, and that what we can try to figure out and identify where is my data, and we fetch that data and we can generate the results or reports as and when required. So this is a small program, but very good program. At least you can understand how the thing performs and how this classical algorithms, PQC, secret key exchange model, RSA key exchange model, then hybrid key exchange model between RSA and PQC, right? And you generated these models, and then the message being generated, which is into the hybrid key model, right? And then finally you try to decrypt by using AES decrypt analysis. Got it? What is the code? This is the code all like what I'm running. I'll just zoom it for you again. There you go. You will find this code. Very simple code, very, very simple code, but try and understand how it works. I hope this concept is now clear. Any doubt? Means really you want to work with the crypto. Okay, great. Thank you, Radha ma'am. Thank you. Great. So my concern is try and understand using crypto is not everything, means every technology is not easy, but to adopt that model we need to think about. Until the time we do not have a proper running applications, running methods, I think it is quite challenging, right? That could be a real-time challenge. So that's how we used to work. And now I would show you another layer. Post quantum cryptographic standards. That's, I think I have already discussed this part. So key exchange model, that is a crystal Kyber. So I have shown you how Kyber algorithm you can implement. Key exchange values. So this is the code which you have just seen. Yeah, PQC key exchange. That's it. That is why Python is quite best to go. Reason, in your Python you need not to write a code, need not to understand what is the algorithms all about, no mathematical explanation, but at least you can know. If you know what is the name of the method, you just simply execute a method, you will get a return of that content, and then simply you can take it for a demonstration or public presentations, etc. Right? This is one of the way how we can try, we can understand. Great. Quickly, we can talk about risk scoring. Can we have a handlers risk scoring model? So that we can also try, and we can talk about what is QKD model. Anybody heard about QKD? Quantum key distributions. So how you can implement QKD, use quantum mechanics to securely distribute the cryptographic keys. So KD is also one of the way where you can talk about, like, you generated the keys and now how securely you distribute those cryptographic keys. So that's another good example. Any eavesdropping means many spy activities, man in the middles attempt to disrupt your quantum states. And if the quantum state is disturbed, it means their hash is disturbed, and hash is disturbed means data tampered, or you simply ignore that packet and regenerate the data packets depending upon whatever the queries you are going to work on. So people prefer also sometimes like QKD model for transferring your keys again in the quantum process. So that's another way. For that, you can just go through with one of the protocol called BB84 protocol. Sender transmit the photon with random polarization, receive the measures using random based, public discussion reveals the matching based, and secure key extracted, and then intrusion detection via error rates. These are the stages, conceptual stages, but yes, these are the stages to implement these kind of protocols. And now further you can design your own protocols or make changes in the layers or add some layers to generate different type of protocols, right? So there you can think about how cryptographic algorithms, some case studies are there. I have, you can try and you can implement on that. So as we are already onto it, let me show you the third example quickly at this stage. Now in this example, what we are supposed to do, there we have a lab 3 and this AI risk scoring for harvest now and decrypt later. That is HN, harvest now, and DL, that is decrypt later. You know, that is what recommended by even PQC models and various other quantum algorithms, right? Because you have to cater everything right now. What do you, don't you think so? Everybody is trying to hack your data, collect your data. This is data era. Everybody is, about your data, your behavior, your activities, your geolocations, your every single information, right? So what they are doing, they're basically trying to harvest. I don't know whether they are really implementing the backend process for their business analytics or for other activities or not. That's a different case altogether. But are they really harvesting that information? Yes. But are they really decrypting it? Yes. Not now. As and when required, they can decrypt it later. They can process things accordingly. So let's say I'll try to make a small example of this particular part using AI ML and score data access based on the quantum decryption risk, identify high priorities assets vulnerable to the future quantum attacks. Can you identify the purpose? The best part is today, whatever infrastructure you have, can we identify the high priority assets which are vulnerable for the future quantum attacks? Understood what is this purpose, why we are working on this kind of algorithms? So support PQC migration decision making. Okay, so this is the target, that really we want to go with the PQC migrations on that or not, or is it still my servers are secure, my application, my infrastructure is quite secured enough? So what we are supposed to talk about: encryption algorithms, key size, data sensitivity, data lifetime, and exposure levels. And major risk factors, that is the encryption length for all these algorithms, key sizes, data sensitivity, that means the severity levels, lifetime, day, lifetime, years, so how long it will take, and sustainability, retention periods, what is the retention period for the confidentiality of that data, and exposure levels. So exposure, obviously we have to give the data. See, in cybersecurity, the three main pillar, CIA, confidentiality, integrity, and availability. But don't forget about availability. Confidentiality, we talk cryptography, integrity, we talk again cryptography like hash or other things. But what about availability? To whom we are going to create the data and who will be accessible for those that type of data? So exposure level is for internal or for the outside partners, or why not for internet public use? So all three stages: private network, protected network, or public network. For that, what we are doing, let's say we have a small sample set of assets. Let's say I have a set size, so I'll quickly show you my sample asset. CSV file is there. So in this CSV, I have a asset ID, I have an encryption algorithm, key sizes, sensitivity level, lifetiming, and exposure level. So this is one of the data set I try to identify from our existing, let's say, infrastructures. Okay, could be any server, could be any algorithm wherever it is being implemented, and what would be the way how it works. So I have some dummy data set, you can say, only for with 5 records, so that my processor can at least perform this task. Okay, and then requirements, I need a pandas and scikit-learn, nothing else. It's a common applications which you generally use. And we have a code for this, how you will handle uh, data. So pandas, you need a label encoder and decision tree regressor, right? Regressors. So I'm using a decision tree regressors. So I hope you know these all ML and AI algorithms, how you can make your decision tree algorithms, or other algorithms. So let's say first we load the data. So we need a pandas library. We create object df, and have a CSV, so that library being uploaded. Then encoders, create a feature engineering for encoders and try to figure out columns, let's say encryption, sensitivity and exposures, label them, fit for your LE model. So le.fit transform, so transform your data into that columns, and you got encoded columns. Then you have a X as an array of df where you have all 5 columns, right? Then we try to define the code, the method, and going to run a code and call these rows. So risk equals to 0 and encryption key, the if row encryption is encoder, that is RSA. So you are trying to, because the data has already been encoded. Now if the data is encoded, you cannot extract. So that is the purpose now. If you have algorithms and if it is exposed algorithm, did you ever try to see the algorithms, exposed algorithms? Let me show you. I think then only you will understand what I'm talking. Just go and open your Zoom and check your secure connection is secure. Did you ever try to show this and certificate is valid? And if certificate is valid, do I get a public key over there? Can you see this? I got a public key. I get to know what are the certificates, which algorithm are you talking about? Can't I extract this information from zoom.us? So think about how many servers are there and from where you will find all these. Even you will get algorithms, RSA encryption, SHA-256. Is it not publicly available? And if it is publicly available and my quantum is ready to hack a RSA encryption keys, how you will mitigate? So I think now you can understand what I'm talking about. From where do I get that data set? So collection of data set is not difficult because the keys has already, already it's being exposed. It is available publicly. You can see DigiCert, Global, TLS, RSA, all things available and clearly mentioned. This is zoom.us. So if you are presently on app.zoom.us, if you are on this particular link, this is what a simple your public key certificate, HTTPS certificate is there. So in this case, if I can get this kind of content, why not my data get encoded? Can you encode? Yes, we can. So what is the best practice to encode? I have shown you the hybrid model. So let's say I try a one encoder algorithm of the encryption to transform the RSA, and I'll got a one row encryption. Okay, so risk level, let's say I just mention some risk level. Again, if I'll encrypt a algorithm, let's say ECC, then a risk level is 35. That was 40, that is 35. And if this is AES, risk level is plus equals to, so plus equals to risk plus equals to risk plus equals to, okay, old value plus this. So this is the old plus new, so total this. Else, if it is PQC, then risk level is plus equals to only 5. Now my concern is if your key factor size, the row size is less than 256, define your risk level. So sensitivity, accordingly you define your risk level. If you have a your data lifetime, so again define your risk level. Exposure, so you got a final one value in the form of risk, that how much risk do you have, divide into various different types of categories of different algorithms. So based on these risks, if we are working, we'll try to incorporate and we'll try to expose that data, and based on that data, try to place it on the base risk algorithms or any algorithm where you can apply. So you got a base risks, total df dot apply and compute base risk axis equals to 1. Okay, there you define a one base risk and just create a model, train your AI model, decision tree regressor, the depth level of 4, and then you define your data, fit your model, and then predict what would be the next risk level. So for prediction, this is just a rule-based model of AI ML, nothing else. It's not a big deal, which I'm showing you right away. But how AI will get incorporated with the quantum part, purpose of quantum. So risk classification, if then you got a risk levels. If score is more than 8 equals to 80, critical, high, so you define your classification risks, and based on that, generate the proper report, generate the results. Let's try to run this code. Want to see that code? Quickly, I'll take you down to okay. So we are ready with the requirements. What are my requirements? This is Panda. Okay, this is already there, so not a big deal. Still, we'll try to execute. That's perfectly fine. So Python, yes, risk underscore scoring. Okay. So based on your AI model, you can predict if a set is this with this level of AI scores, and they'll give you the level of severities. जितने scanners बनते हैं, I don't know whether you really figure out the vulnerability scanners. Check, I'll give you the name of those tools, like Zap Proxy. You can try that is an OWASP product called Zap Proxy. You must try that. Otherwise, you can make one server. Open source server is OpenVAS. That is vulnerability assessment scanners. OpenVAS. They got a data set from NVD, National Vulnerability Database. We got the database from NVD. We download that database and synchronize with the OpenVAS servers on Linux. And based on that, we do infrastructure audits, vulnerability assessments. And we got a list in the form of severity levels, the risk levels which are there. Again, you're getting at this time in front of you. So can we create those applications or some report generational tools, scanning tools? So this is a small prototype of a scanning tool to identify the applications which are vulnerable, and those applications which are running with these algorithms, and these algorithms are vulnerable, and for what is their risk level, where we have to focus more, because a high level risk need to be focused on a very urgent basis, and pick these algorithms, locate these infrastructures or applications, and on that try to mitigate, because otherwise the quantum will gonna create a problem for those application or those infrastructures. Got my point? How to handle and how to mitigate the risks on these areas. Any query, any doubt at this stage? Acha sir, I think I can see my public key as it is on my user side, but others won't be getting the public key while zoom.us is getting accessed. I don't know why, but if you are let's say on any browser, please check why the others are not able to access Neeraj. It is I am using a Chrome browser presently. I just click on the icon where you have this lock or padding lock, or because I have shared a screen and my camera is accessible, that is why you can see it is there. And then there is an option, and it is in Firefox, it is in Safari, it is in Edge. So I don't know, whatever browser you are using, please go and access that. But if you are using an application, if you are from a Zoom application, probably you cannot see directly because Zoom application have a backdoor link to their servers. But if you connected with the browsers, so please go through with the browsers, find the link, connection is secure. Even you can open any other website, any website. Let's say we'll go to the banking website, SBI. Do you have SBI? And I need to check SBI link. Okay, SBI link website, you can see this is also, just go and check on the padding lock area, so there you will see connection is secure. Same thing, it is very common. And if it is a connection is secure, if you just see connection is secure, just go there and find the certificate of this valid. And certificate, you will find it is RSA CG2. You can see public key availability of this SBI website. This is again SHA 256 RSA, and public key and their certificate of this website SBI bank. So not only Zoomers, you can find for any website, because that is public key. It's a public key you can access. It's not a private key. You can access public keys from any website. All these applications are giving you the details, but now these footprints will create a problem, because tomorrow if somebody apply quantum attacks, on your RSAs or other algorithms, and they get to know which algorithm you are using, what is the the keys you are using, encryption algorithms which you have, all the details are available. See, this is what you can find it. Got it? I think Mr. Neeraj, yeah, Neeraj, is it clear? Yeah, perfect, okay, great. So see, the keys are available public. That's a footprint. Now how hackers need to pinpoint? Hackers are pinpointing based on your footprints. And now we have a keys footprints, we have algorithm footprints. And if these footprints are available, and all web servers, web technology need to be revamped. If RSA is in, because RSA in danger, and quantum will gonna attack your RSA, so then how you will work out? Right. Great. Thank you, Gadge Radhaji. Thank you so much. Krishna Raoji. Thank you so much. Thank you. Hope that concept is quite clear to you. So that's what my target is, to take you towards the research work. I think I talk ample of things today, in fact, and try to figure those areas where you can research, where you can take your research level up to next level, right? See the next potential threats, and we are planning for that. We are writing prototypes right now for that. That is on the stage where we all have to work across. In fact, we are looking for some interns also. If they can connect with us, they can also come and incorporate with us to write these kind of prototypes. We'll give them high complex problem statements. Okay, do this, do that multiple, 100 and 200 types of problem statement queries, and that we need to incorporate, and then we create some prototype sort of, and try to apply on some websites, or so if you are really interested, please, we can connect for certain things as well later. Great. Thank you so much. I will share certainly, before I end up my session, then only I'll share. But I have quickly some more programs. I think only I have a half an hour approximately left. So let me complete first these experiments which I try to make it for you. Right. Let's come to the fourth one. So I have 6 good experiments I prepared for all of you. Now, what is this fourth one? That is why AI is critical in the quantum security era. Right. And what is the role model of AI in quantum security area? So this era is like data era, as I said, and now very soon we are going to enter to the quantum security era, because data is now everywhere. Then once you collect the data, as we worked on harvest now and decrypt later, as I have explained, but the day you harvest, then what happens? Then you want decryption. How you will decrypt? So what you will harvest, where you will harvest, what's the process, how to figure out, is it a structurized data, means according to the ML language, if I'll talk about, like whether it is supervised labeled data or unsupervised unlabeled data, or corpus format, text files, any multimedia data to be converted by either by their artifacts or by some data retrieval systems like conversational AI applications, and like Siri, Alexa, or whatever, we take that data. Now everything you have, and you collected your raw data, you harvest your data now. But now if you harvest your first challenge is how to and where to save the data, harvested data. But on real time basis, I believe we don't harvest the data. Do you know? These are the two queries, two different level of queries. Are you on a real time data analysis, or you are on a static classical data analysis? If you're on a classical data, means your data is on the rest mode. So you know, data is always on two different modes. We are into forensic science, so you know, we take it, the data, into three different categories: data on the rest mode, data in motion, it means it's moving, data in use, generally that data in RAM, data in use. So three major categories where we consider data these days. Okay. Data in rest, you already have examples. I hope many of the speakers also discuss about these things. And if you even go and talk on chat gpt or other AI tool, I think you can solve very many algorithms are available today. People who are learning AI ML, they are learning data in the rest. What about data in the motion? Data in use will be taken care by, again, other different examples. And we take RAM dumps. We got a RAM dump, we create a hash of that RAM dump, and further we can analyze at what time what application was running and what was their keys. Means today, right now, the number of tabs if you have opened, and right now if I'll come and take your RAM dump, tomorrow or later, if it is a evidence, it's a some related to some legal case, say for 18 years the case will goes across in the courts. Can you imagine? Still I can give you the data, what was there in that machine at that particular instance, which network was connected, which IP address was there. So all multiple parameters. And why not cryptographic? If your data is crypto, today we are talking about data cryptographies. Your data is not on a plain text. 99.9% servers are on HTTPS. So if it is HTTPS, it means encryption, it means TLS, it means SSL. So if all these algorithms are there, 99% data is encrypted. No man in the middle attack is possible. This is generally we used to call. But quantum will do it. How quantum will do it? How quantum will do it? So the threat, the threat is from quantum side, not from handling your data and all that. So if your data is on the real time basis, data is in motion, going on. Let's say in your campus, please allow me to come and I will connect my laptop in your Wi-Fi or in your LAN with obviously due permission, right? And if I'll run one application, and randomly I'll try to identify your devices, your gadgets, your flood of the traffic and all, and I want an analytical part, I want top 10 IP addresses using consuming your bandwidth and many more things which can be easily calculated. But are they using VPNs? Are they using somebody is doing some nuisance? Are they using Tor networks? Are they using dark webs? Are they using some objectionable sites? My concern is, if I'll have a AI ML trained model data set with their algorithms, with their RSA algorithms, or whatever the level of algorithms or the keys which they are using, because generally, I hope you must be aware of these digital certificates and digital signatures being provided generally by the one of the authorized one of the CAs, certifying authorities. And certifying authorities have a signatures. They have their own unique signatures of each certifying authority in your public keys. That is why once you start your new website, any new random website you try to access on a browser, and at that time you do not have a public key, then how HTTPS perform? How HTTPS perform? Then you need a public key to access that website. Otherwise, you cannot able to access that website. Right? These are the basic terms. These are very, very basic terms. Now, if it is something like that, this is the way how HTTPS protocol performs, or then you're talking about TLS and all. So now data is all encrypted and some signatures. Can we, on a real-time basis, if I'll run like Wireshark, hope you heard about, from the network traffic protocols and all that tools where I can capture, it's a sniffer, I can capture your data packets and all. So I will get a huge data set. From there, I harvest some network information. Once I harvest that network information, I collected that information, and if my AI model is already ready and trained, they will let me know. They'll give me the idea which interface, which device is more vulnerable, quickly more vulnerable for quantum attacks than any other. So I have given you the examples for this. This is a real-time live examples for this. I hope now you understood what is the real purpose of doing all such things. So what is the critical in quantum security era? New cryptographic algorithms, PQC hybrid cryptos, increased attack surface, massive data volumes, faster and more complex attacks patterns. Right? So patterns, complex attacks patterns, how you will manage, how you will identify. So what is the role of AI? That is a so that is a predictor for quantum threats. It could be an optimizer of security controls. It could be automator of cryptographic migrations, and amplifier for human decision making models, predictions, and many more things which we are doing. Sentiment analysis, prediction analysis, behavioral analysis, and many more things. So I think we can go on that, right? And quantum threats and risk assessments. So for that, like quantum threat modeling is like AI model simulations, like quantum capabilities timelines, how much timelines quantum will take. So algorithm specific break probabilities, sector specific risk exposures, because sector specific means, do you know, Are abhi wana Venezuela attack by US. They did a cyber warfare applications on their digital grid, complete power down, digital, all the grids were digitalized in Venezuela. This is what the real time recent attack, cyber warfare attacks implemented. They're all digital gadgets. Why all digital gadgets? Especially the grid system, all grids being you know uh, simply controlled and hacked by US Army and US cyber warfare teams. Can you think of that? The main major problem is patterns. a common platform which we are using, the common tools which we are using. That is why, to be very honest, I think our government take one initiative the day our Prime Minister, Honorable Prime Minister Modi ji came, and they launched one project called Digital India, Make in India project. I think being into academicians or being into IT professionals, we have not taken it seriously. Please take it seriously. India need Indian infrastructure, Indian platform. Otherwise, we'll be in trouble. Same concern would be happen like the recently in Venezuela it happens. The grid, they have a common part and they have a common infrastructure. Specific sector risk exposure was there. They have a same softwares, they have SCADA, they have simpler network, they have common applications, common platforms. Same thing happened for banking. What about ATM machines? Which operating system used in the ATMs? All common applications, common applications. So the direct risk factor is one single attack implemented by quantum, the entire business unit would be collapsed. It collapsed like anything. And this is a real problem statement came in front of us in US Venezuela attack, right? And their entire grids being down, being compromised. So try and understand that is another level of models. We have various other technologies which we can implement like Bayes. I think this is what recently we are already using. Bayesian networks, Monte Carlo simulations, time series forecasting models to predict and to identify and to pattern recognitions and all that. I think we can use these kind of technologies to build a quantum threat models and to understand all these models. Cybersecurity applications prioritized with the cryptographic assets to mitigate first and then predict with the same model. HNDL, that is harvest now and decrypt later risks. But at least you should have a data set. Data set ही नहीं होगा किस पे आप experiments करेंगे. Then there is no point of quantum if you don't have a data, if you don't have a query, if you don't have a problem statements. Then what you will harvest from that data set, right? What you will extract from those existing models. So AI predicts the ECC based PKI and BFSI facts faces a higher risk than AES 256 protected storages, and this is how it's being driven. And especially AI driven cryptanalysis, that is the defensive research models which you can get into it. And then AI can obviously detect the cryptographic weakness, identifying poor implementation. I have just given you the example of cryptographic weakness, and how long it will take and what are their risk level. You can identify and make a proper vulnerable infrastructure identification models, as I have shown you right away in my previous code, right? So identify poor implementations and analyze side channel leakage patterns, etc. So defensive values and all that stuffs are there. Post quantum cryptography migration. What is migration challenges? Thousands of crypto dependencies, legacy systems, performance uncertainty. So a lot of challenges are there. Again, even we cannot directly go and migrate, right? But yes, we need to think about their compliance issue. In fact, compliance is a major issue also these days, right? So still you want to migrate. What is the workflow model? Create your crypto inventory discovery. So I have given you the way how you can create a crypto inventory discovery. Then I have given you the another program for risk classifications. You can apply the algorithms for recommendation, how you can implement the PQC replacements or hybrid classification, classic encryption and PQC encryption in one go. So I have given you one code for that. Then further you can take it for performance predictions, latency time, throughput, impact modeling, everything which you can extract from from PQC migration, and based on that only you can decide what is the best practice to go for it. All right. चलिए time कम है. I think first I'll show you the code. Rest theory I will share all these points to all of you. I'll take you. I think this is done, and this is the third one. Let's come to the fourth one. Let's say we'll come to the fourth lab. AI-based quantum awareness of IDS, intrusion detection systems. How many of you really worked with the intrusion detection systems? How IDS is different from firewalls? Even today, we don't talk only about IDS. We always talk about IDPS, intrusion detections and prevention systems also. What is the difference in, okay, if I'll ask you very general, can we identify the malwares, viruses like using firewall? Yes or no? You can write on comments in the chat. By using firewall, can we able to identify the viruses or any other malware? Yes or no? Okay. Many of you are saying yes. Lakshmi Khan said not properly. Okay. Well, my answer is okay. So good. Dr. Vineet said not exactly. See, there are very general terms in cybersecurity. Please try and understand. If you are using a malwares and you want to identify the malware, we want anti-malwares. And firewall is not an anti-malware. Please try and understand. So my answer is completely no. Completely no. Right? Now I'll talk. And that is why I really appreciate the people who said not exactly. I really appreciate the people who said not exactly, because what is the possibility and what are the not the possibilities, we need to understand. For malwares, we have anti-malwares. You have antivirus now to identify virus. You have anti-worms, anti-trojans, anti-ransomwares, anti-rootkits. Are these applications are incorporated in firewall? What is firewall? You talk about hardware level firewalls, which are on the network side. So network based firewalls, host based firewalls are there. Please try and understand, the firewalls are not at all the malware identification model. Firewall is like a security guard sitting on the gate of your organization, let's say. So that is a firewall. Their job is to check the student ID card. If you are having ID card, okay, move in. But they are not supposed to open their bags, what they are carrying in their bags. One packet which is coming to the network. So firewall is a security guard who will check this protocol. I appreciate this protocol. I admire this protocol. It is allowed. Please accept. This IP address, okay, accept. So firewalls are working on IP addresses. They works on protocols. They works on some policies on the common parameters of the networks or of any application which is there on your system. Incoming policies, outgoing policies from the gate from where you are receiving the packets. These are the firewalls. But my concern is, if there is a massive entry in the morning timings, is it like the security guard is really checking the cards of everybody? Is there anyone who can trace that, yes, this is my student and this is not a student, that could be a friend of the student is entering to the college without a permission? Who will identify? Then you actually deployed CCTV on top of it. CCTV will not stop that student, but you maintain that CCTV. Right now you are just maintaining for any incident response. any incident being occurred, then you explore CCTV. No, that is not only CCTV for today. CCTV for today is to the day the student enter to your premises, that is to be face recognition system by Python will identify, and they'll give you, this is the name of the person, this is the photograph of this person, this is a student of this class, and they're entering to the premises or exiting to the premises. Are you getting my point? So CCTV, how you handle that data set? Your data is moving in such a way, but CCTV won't say anything. That CCTV is an intrusion detection system. That is IDS, and that is not firewall. Firewall is your security guard. Please try and understand the two different strategies. But if I incorporate both of them with preventive systems, that somebody sitting on the back end watching CCTV and they got one unknown person is entering to the premises. So the person sitting on the back end will call to the security guard, hey security guard, just go and check that person, that vehicle, why that person is entering to the premises, what they want. I believe they are doing some anomaly behavior. Can we do anomaly detection techniques? So I want preventive system also at that time. So today we talk about the people who said not proper, not purely or correctly or not exactly, most of you said, right? Not exactly. Now why you're not exactly is correct, because today we don't have only firewall, we have UTMs, unified threat models, which is incorporated with the firewalls, incorporated with the IDS, incorporated with the IPS, and new policies, the behavioral policies, which is about to enter into the with AI and all of it, anomaly detection, and very soon it will come. It's still expensive firewalls like FortiGate, Cisco, they don't have such features. Still they don't have such features. Take my words. They have UTM, multiple activities, let me incorporate in one machine. This is what they are doing, nothing else. So that is why the people who said not exactly is the correct answer, not properly. And that's why I said no, firewall would not able to understand what the packet you are talking about. If my packet is HTTPS, but it is coming with a malware, if HTTPS is allowed, firewall will not check the content of the packet. They will say you are running with HTTPS, go ahead, let it go. They will not block your packets. Firewall will not block your packets if it is a malware, right? For identifying malware, you need anti-malwares. So please try and understand these are the challenges. And now anomaly detection with quantum awareness becomes more easy if I incorporate with AI. So IDS, I hope now you understood IDS, traditional IDS system. Now you understood what is the quantum IDS system, AI IDS systems, anomaly detection in the quantums. Now think next level problem statements. So in traditional IDS, we have only static rules. We have signature, dependency, cannot adopt a new attacks vector. Presently, our security system is on this model. Our complete Indian, traditional cybersecurity infrastructure is on this model. Indian, and this is the real threat for our country. Let's say we are in AI, why not we incorporate AI with the other various things like isolation forest, autoencoder algorithms, unsupervised learning, behavior profiling, context awareness, anomaly detection. I have already worked on that, and the code and applications are ready. We are working on that. But what about realistic data traffic, quantum era use cases, detect the abnormal cryptographic behavior? So you can identify ransomware, identify forged quantum safe signatures. The signatures which are already safe must be in my data set, correlate. If everything is fine, let it go. Otherwise, identify and block, because now your traffic is completely encrypted. So what is next level of hacking? Monitor hybrid crypto negotiation anomalies. And to work on such model with a high data set, we want quantum era. We want to enter to the quantum era. We want a quantum based SOCs, you know, security operational centers and SIM tools on that basis. Hybrid quantum AI security architectures need to be implemented. So these are the areas where we are supposed to talk more in depth. And then you realize what we are supposed to talk. अरे बहुत सारा है, but okay, quickly, I think time is very very less. अच्छा, almost I exhausted the time. I'll show you. My lab force is that AI based quantum awareness intrusion detection system. Now I want these things to be incorporated: AI, then quantum, then IDS. I think now you understand what I want to perform at this ground. Features. So why quantum and all that feature used for detection? What I'm using: handshake time in milliseconds. How much time it will take for the handshake? Time taken for crypto handshakes. Key size, negotiated key size. Algorithm type, classical, hybrid, or PQC. Failed handshakes, how many times it failed for the handshakes. Packet rates, packet per seconds, session durations, etc. So I have new features, new parameters, different parameters for AI, quantum, and IDS. These are the different, completely different parameters for research work. For that, I have a small code, I have small network logs and some requirements. So network logs are like just in this way. These are the headings. I have some values placed in the CSV file. I need pandas, scikit, learn, and matplotlib for demonstrations and all. And finally, I need a code. There I got a code. I just import these files, use CSV, make a DF object from pandas, go for label encoding, transform your data according to that label encoding. Features need to be extracted, so just label them accordingly. Then go for a standard scalar algorithms and fit your data with the scalar.fit.transform all the features, so that becomes X scaled model. And use the isolation forest model, right? Isolation forest model for your IDS model, your estimators, uh, contamination up to 25%, random state 42 is always good to go. And this way you make a predictions of IDS models, deploy, correlate. I think you know anomaly detections and all. This isolation forest is the algorithm which you can try. So on that basis, simply make a result and generate some reports, correlate, predict, go for prediction analysis, correlations, behavior analysis, and visualization in case if you want. So there you got a code, and finally we're going to get a CSV file for the report. Let me show you, and I'll run this code the earliest way. Okay, I have requirements all satisfied. Good. Name of the file, I have quantum. Okay, so finally I got a complete result in the form of pandas and uploaded with a isolation forest, and you can find anomaly behaviors. This is the attack, this is a classical attack, possibilities, and normal. So this is normal behavior, this is attack. So you can identify the attacks based on various different ways. This is PQC attack going on. Let's say we can create something like that. I hope this concept is quite clear now, right? Uh, time is very less. Then PQC, I'll show you the code directly, I believe. I have one more code for AI based PQC algorithm recommendation system, which why means how you can incorporate AI with PQC algorithms. And the purpose is there is no single best PQC algorithm. So we need to make multiple permutation combinations sometimes with the various different algorithms for the various purpose for security, performance, optimization, key size, bandwidth, compliance, and many more things. So for that, we have again 5 good parameters, use cases, that is TLS or whatever, latency sensitivity, bandwidth constraints, security levels, compliance required, etc. And algorithm consists of could be a Kaber, Delithium, or we use other algorithms as well. So I have a code again, simple CSV file with the same data set. Okay, and I use again same pandas and all to figure out by using decision tree classifiers. So I think you can also do, not a big deal now. If you are good in Python, I think you can understand what I'm doing. But my now data set is different. That is little unique because my major part is what type of parameters I need to select for handling such issues. So if you have a relevant parameters, compliant parameters with the good data set, and then automatically your AI ML will work. Rest, you have a common algorithm which you can try. I'm just using decision tree classifier. On that, you will run and you will get a final output. I already have output. Let me show you directly the output. This is how it is being use case, latency, bandwidth, security, compliances. You will find all the cases as if I'll run the code. Fine. And I have a quantum forensic side. And for the forensics, AI driven quantum forensics for encrypted traffic and metadata retrieval, same thing we can do for that. So I took up one particular crisp of quantum, the secured communication channels, consider certain parametric part, infrastructure part, intrusion detection side, right? With the latest algorithms like PQC, as it is always commentable, okay, and quantum, the threat level of quantum and how to mitigate the threat level of quantum. So I have shown you 6 good experiments on these layers where you can work, you can encrypt, and you can try to create a zero trust environment. So which hardware, which infrastructure, I think we can predict. And if we can predict, quickly we can go with a zero trust environment of hardwares, and then their parameters accordingly for forensics purpose. So metadata will fetch the metadata, event time, source IP, destination IP, number of packets, total bytes, duration, crypto handshake time, then algorithms used behind that, and failure attempts. On that basis, we try to figure out what all the content all about, and then try to implement by using some standard scaler, labeled encoded, then standard scale, so labeled all the data, synchronize the data, standard scalers, then we use a DB scan algorithms for clustering, right? And then plotting, etc. And then you can figure out with AI. And you have time visualization. We can go with time series management, very good and important part of it. We can have a timestamp, how much time taken by transferring such packets from so and so specific IP addresses, and transmission details, and we can go for suspicious activities identification. So this is all about, I think we can go and extend it with the DB scan with isolation forest, LSTM time series models. I think there are many ways which we can now incorporate, and we can further extend this project. So on this ground, I think I exhausted your time, and all I'm through with the content. Also, I'm open for the question answers, and I'm through with my content. Anybody have any further queries? So I am open for question answers, and thank you for the patient listening. I hope I try to make it more practical, more next level challenges to be discussed. And I think I try to give you many new topics for the area of research and for your innovation. If you are interested for, uh, you want, I will share my contact details also on the chat. This is my mobile number, and my name is Dr. Anup Girdhar. I'm a CEO with the Sedulity Groups, and it's been 30 years I'm into a technology. I'm a practitioner. I do a lot of practicals, and that is why I try to solve some problems for you. Okay, some Veni Tyagiji saying, can we use a auto ML library like H2O for featured engineering? Why not, ma'am? Why not? Vaniji, certainly you must apply these kind of algorithms. That is why I said on an open-ended platform. Now, my purpose is, see, you have a featured engine. You're talking about like auto ML part. That is a one way of handling of data. What is the purpose of it? Whatever the purpose, you can apply. It's open ended. It's a completely hybrid technology, open ended technologies, and that is a good time to complete the PhDs or your scholars who are already associated. Please go, and this is a good time, because right now no more patents. You can go with patents. No good areas of with quantums. People are still having a lack of knowledge. So this is a real good time, and now we can have a great permutation combination of various different algorithms, different stages, different patterns, different models. Even we have different models of AI. We try to incorporate those models and then try to generate new results. Probably you will get something out of unique, and then I think we'll take your name for Nobel Prize for India. And why not, we all can think about, because Indians have a good brain and we have a different mindset, and we can go in that way. Wonderful ways. Certainly I appreciate. You must try whatever your expertise. Now you please place your expertise in this quantum and some quantum keywords. This post quantum cryptography, or I shared one more protocol, MQTT model, because you have a real time data handling, IDS handling. That's what I try to cover. Many more things with security, forensics, AIML algorithm, whatever AIML, huge AIML model, and then let's correlate with quantums. And I think we can generate many more new things out of it. Thank you so much. I got a great feedback. Thank you for all your valuable words. It's really mean to me, uh, for your valuable, uh, messages. I really appreciate. Thank you all. So I think
Thank you very
done.
much,
Yeah.
Dr.
Thank you.
Anup
What do
Girdhar,
you
sir,
have?
for such
Yes.
an insightful, informative, and thought-provoking session on quantum cryptography, a new security paradigm, and quantum computing in context to cybersecurity. Your session beautifully highlighted the transformational impact of quantum technologies on modern cybersecurity and clearly explained how quantum computing poses both challenges and opportunities for existing cryptographic systems. The way you connected theoretical concepts with practical cybersecurity implications was truly enriching and highly beneficial for all the participants. On behalf of the whole organizing team, I would like to express our sincere gratitude to you, sir, for sparing your valuable time, sharing your vast expertise, and guiding us through such an advanced and emerging area of research and practice. Before we wrap up, I request all the participants to please switch on your cameras for a group picture and kindly fill out the feedback form that has been shared shared in WhatsApp group and on the chat box also. Dear participants, please switch on your cameras. Pavan sir, is it done?
Yes, done. Thank you so much, sir.
Thank you, sir.
Thank you all. Thank you for the great interaction with your wonderful team, wonderful audience. I really means enjoyed while discussions to all of you, and thank you for the privilege. In case even still some question answers left, so I have shared my number. They can connect me later as well, right? And I think we can talk more in details. Thank you. All the best. Thank you. God bless you
Thank
all.
you so much,
Thank you.
sir.
Very
Thanks
nice
for
session.
the valuable
With
feedback.
that, we yeah, with that we conclude session 10. Please fill out the feedback form. As you all know, it is very valuable for us. And some important notes are there. Tomorrow is the last session for our FDP. It will be starting from 2 p.m. onwards. So you all have to join before 2. It means you should be there at 1:45. There will be 3 sessions. They are scheduled for tomorrow. After all these sessions, they'll be wrapped up by 6:30 p.m. After that, there is a assessment test which will be held at 6:30 p.m. to 7:30 p.m., which will consist of 25 MCQ type questions. All the details has been shared you on your emails and the WhatsApp group that has been made. So thank you so much, and with that I officially